Hi folks, we're back with an analysis of the data that we just barely had time to collect for the Once Upon a Penny lab. So if you remember, we were talking about a little boy playing with his shiny copper pennies, we did some measuring on the scale, we did some measuring with rulers, we did some measuring with water displacement, seeing if you put the pennies into a graduated cylinder full of water, what the change in the amount of water was. And of course that was the volume of water the pennies displaced, which equals the volume of the group of pennies you put in. So just as a review of the things we did, we used a centigram scale to find the mass of the pennies. We measured 20 instead of 10, so make that change on your lab sheet. In the chart here that says mass of 10 pennies, you want to change that to 20 pennies. So we found that 20 old pennies had a mass of 60.52 grams, and 20 new pennies had a mass of 50.08 grams, both 4 significant figures. We divided those numbers by 20, since there were 20 pennies, to find the average mass of 1 penny. Of course, this is just something we did to try to reduce the amount of error. Perhaps 1 penny might have a little nick or chip out of it, and its mass would be a little smaller. 1 penny might have a little bit of dirt clinging to it, its mass would be a little larger. If we find the mass of 20 pennies, hopefully they'll average out to be a little bit more close to the truth. So we found the mass of an old penny to be on average 3.026 grams, and the mass of a new penny to be 2.504 grams. There's a slight difference that you can see there, which is important. Then we calculated the volume of a penny by measuring the penny with a ruler. So we know that for a cylinder, which a penny basically is, a little flat cylinder, volume is pi times the radius squared times the height. So we did pi, and then we measured the radius of a penny with a ruler to be 0.940 centimeters, which we're going to square. So make sure you know how to type that into your calculator. Times the height of a penny, which I got from the United States Treasury website, which is 0.123 centimeters. We could also measure that with calipers, which have a higher degree of precision, meaning more significant figures than a ruler. And we found that to be, oh, the baby erased a little bit of the board, which we found to be 0.341 centimeters cubed. We have centimeters squared times centimeters cubed. And we know that a centimeter cubed is also equal to a milliliter, so we would expect 1 penny to displace 0.341 milliliters of water, or to have a volume of 0.341 milliliters. We calculated that mathematically. Of course, later we're going to actually stick those pennies into the graduated cylinder and see how it compares when we actually measure the displacement of water. So here, then we can find the density of the penny, the mass divided by the volume. We have the mass of 1 penny divided by the volume of 1 penny. So for old pennies, we found the density to be 8.87 grams per milliliter. For new pennies, if we divide the mass of the new penny divided by the volume of the new penny, we found it to be 7.34 grams per milliliter. You should have those charts filled in as this first chart here on your sheet, and you should have all gotten these answers. If you didn't, check your work. If you're stuck, please call me. So you see that there is a significant difference between the density of the old penny and the new penny, but we don't really know why yet. So remember, our little boy was kind of baffled by that too. And here's an example of the calculation, how I found the density of the old penny, dividing the mass by the volume and coming up with the answer. Did the same thing with these two numbers for the new penny. So remember, the little boy thought, well, what do I do? So then we're going to find just another way to measure the density. Instead of using the ruler to measure the penny's volume and treat it like a cylinder, we're going to actually find the volume by displacing water. We put those pennies into the graduated cylinder. We noted how much water there was before we put the pennies in, how much water there was after we put the pennies in. then we could calculate by subtracting how much water was displaced by the pennies, and that would equal the volume of pennies. So one group did this with 20 old pennies and one group did this with 20 new pennies. The group that did it with 20 old pennies found that 20 pennies displaced 6.8 milliliters of water. The graduated cylinder water amount went up 6.8 milliliters when they added the pennies, 20 pennies. So if you divide 6.8 by 20, then you get the volume of 1 penny, which they found to be 0.34 milliliters. Of course, we have fewer significant figures doing it this way than we did doing it mathematically, just because the graduated cylinder can only get us 2 significant figures in this case, whereas the ruler could get us 3. So here we found the volume of an old penny to be 0.34 milliliters, which compares very closely to what we found up here, the volume of an old penny being 0.341 milliliters. So we are very close to the same answer both ways we calculated the volume of the penny. Now when we put the new pennies into a graduated cylinder, the group that did that found that 20 new pennies displaced 6.9 milliliters of water. So they calculated the volume of 1 penny to be 0.35 milliliters. And then we use the same mass, the old penny mass, divided by this volume. Then we can only keep 2 significant figures, because even though the mass has 4 significant figures, the volume has 2. So we keep our answer to 2 significant figures, and we would find that by volume displacement, the density of an old penny would be 8.9 grams per milliliter, which is very close to the other way. These two answers compare very closely, which is good. And then we would find the density of the new penny, this mass, 2.504 grams divided by 0.35 milliliters, 2 significant figures, so we keep 2. We found the density of the new pennies to be 7.2 grams per milliliter, which is still pretty close to what we found up here. So it's going really well so far, but we still don't have an explanation for why the old pennies and the new pennies seem to be so different. So remember, the mom came at the end of class, saw the little boy playing with the pennies. He was about to wash them because he thought maybe the old pennies gained weight because they were dirty, and then she chopped them in half. So I can't see my camera, so I'm really hoping I can get a good shot of this. I chopped 2 pennies in half, an old one and a new one. You can see, hopefully, the inside of the old penny looks copper colored all the way through, like it's made of one type of material. The inside of the new penny, however, has a thin copper coating, but you can see a silvery color on the inside. You can see that this penny is made of a layer of silver metal covered in a thin layer of copper metal. So we don't know what that silver stuff is in the middle of the new penny, but we know that it's different than copper. We can see that it's a different color. So that might start explaining something. So here in our story, the mom chopped the penny in half, and then he looked at them. He saw that they were made of different things, and then he checked the precious metal section of the newspaper, and he was shocked again. So if you flip your paper over, I give you a list of densities of common metals here and the price per kilogram of these common metals. So I think, based on our data, you can make some predictions about what old pennies are made of and what new pennies are made of. Then you can finish the back of the worksheet here. I think we've covered a lot of the things in class that you were asked about on the back of this worksheet. You don't have to write a full lab report. You just have to complete the front and back page of the Once Upon a Penny worksheet. And I just want to see your best attempt at answering some of these questions based on the information I've given you. And then I can go over it a little bit with you, and we can make some corrections if you don't fully get it the first time. So then we have kind of the sideshow that was going on in our lab activity with the 2 cylinders. And I think they'll also help you, even though there wasn't a place on the worksheet for those. I think that you might find what we learned from those helpful. So we had a lab group with old pennies and a lab group with new pennies. But this year, for the first time, I also had a lab group that had a cylinder made of copper and a cylinder made of some other metal that's silver. It looked a lot like that silver inside the new penny. So maybe if we could figure out what that stuff is, then we would have a known of the copper and a known of whatever that silver stuff is, which I bet, based on what you know, you can figure out from the chart on the back of our worksheet. So we found those cylinders to have a volume mathematically using this. Volume is pi r squared times height. Just like we found for the pennies as a cylinder, these cylinders also. So we found the volume of those to be pi times our radius squared, and someone measured that radius. Both cylinders were exactly the same, 0.625 centimeters. So there's the radius, and we'll square it. And we found the height of that cylinder to be 4.98 centimeters for both cylinders. So the volume turns out, when you type that into your calculator, 3 significant figures here, 3 here, so we can keep 3. We found that volume to be 6.11 centimeters cubed, which we'll call milliliters, because a centimeter cubed is a milliliter. So then we found the mass of those cylinders. We found the copper one to have a mass of 54.28 grams on our centigram balance. So its density would be its mass divided by its volume. So 54.28 grams divided by 6.11 milliliters is, let's see, I did that before. I can keep 3 significant figures here. Oh, I didn't do it. I did it for the water displacement. I don't have a calculator to hand either. So by water displacement, I found it to be 9.0 grams per milliliter. You can type that into your calculator and make sure I'm right there. This should have 3 significant figures. I gotta have a calculator. I can't stand it. Hold on. Okay, so we'll do 54.28 divided by 6.11. So I get 8.88. I can keep 3. 8.883. So that'll be 8.88 grams per milliliter. So this is the copper cylinder's density. The silver colored, which I hope you figured out what it is by now, that cylinder had the same exact volume. We found its mass to be 47.52 grams. So if we do the same thing, 47.52 grams divided by 6.11 milliliters, let's see, 47.52 divided by 6.11, we found that to be, oh fun, 7.78 grams per milliliter. I can keep 3 significant figures again. So this is the silvery colored one. It's not silver, by the way. So if you look at that chart of precious metals, you would see this first column here of densities. You might be able to figure out, well, copper's density, for example, on this chart, the known density of copper is 8.92 grams per milliliter, pretty close to what we found the copper cylinder to be. So if you compare this one to the other densities, I'm sure you can see what metal it's made of. Also, remember that density is an intrinsic property, meaning that a copper penny that's fully made of copper has a density about 8.9 grams per milliliter. If I had, a car-sized brick of copper, it would still have the same density. All copper has that characteristic density of 8.9-ish grams per milliliter. And so it's easy to identify materials, and especially metals, by their color, coupled with their density, which is an intrinsic property, and a few others, such as specific heat, which we'll learn about in 2 weeks. Once you know several of those properties about a substance that you don't know what it is, you can identify it, which is kind of our goal here. So I'm sure when you look at what the metal that's in the middle of the new pennies is and what the price per kilogram of that metal is, you can probably start to answer some of these questions on the back of this worksheet. If you have any questions, I'll be glad to take phone calls, emails, or answer them in class. So sorry we didn't have time to really talk about the lab in class, but I think you'll find after the first 3 weeks of chemistry the flow will be a little easier and we'll be able to cover everything we need to. There's just so much to learn at the beginning of the year. I want to get you up to speed as quickly as possible. So I'll see you on Tuesday and hope you're having a great day.